Beissbarth Microline 1800. Obtain a good yield even with a low vehicle throughput. Measurement preparation. In order to prepare the wheel alignment measurement, record the customer data first. An additional inspection list will make it possible to document possible damage at the vehicle for the customer. Following that, the vehicle will be selected. During the preparatory work, some important vehicle-specific instructions for the wheel alignment will be given. The vehicle make used here as an example is a Passat manufactured in 2005. The close cooperation of Beissbarth with car manufacturers involved will make it possible to call up the factory data and a large number of pictures of the vehicles involved, as well as the vehicle codes for almost any make of car to be checked. The relevant vehicle-specific information will be traced in the Beissbarth vehicle database. Following that, the clamps and sensor heads will be installed. Standard measurement. Once the clamps and the sensor heads have been installed, a wheel run-out compensation will be done as the first step of the standard measurement. In order to do so, the vehicle will be lifted and the wheels be turned by 360 degrees in the direction of motion. The measuring data thus gained will be imported automatically by the program software, fed into the database and displayed on a user-friendly interface if required. The next step is the caster sweep to check the caster angle, the toe-out on turns and the KPI. In order to do so, the wheels will be turned either by 10 or 20 degrees. A comparison now shows the deviation of the actual values from the standard values. The values thus established will be presented in the measuring protocol either in tabular form or as graphs. A possible incorrect position of the wheels will thus be indicated in all detail and clearly arranged, so that any misalignments can be easily corrected during the subsequent setting work. Adjustment work. In order to rectify any possible misalignments of toe, camber and caster angle, the wheels will be aligned to the geometrical driving axle. The modifications to the wheel alignment thus made will be recognized by the software and automatically updated in the graphic presentation. In order to make the setting work easier, detailed vehicle-specific sketches and photographs from the original workshop manuals will give hints on how to go about the job. Final measurement. In order to document the modifications made, a final measurement will be made, again with the help of the turning routine. The measuring protocol will record both the initial situation and the settings made by the workshop. Microline 1800 offers the following measurement options. A speedy measurement makes it possible to establish the static values of toe and camber in a time-saving mode. The standard measurement, as it has been demonstrated, will facilitate the comprehensive and detailed establishment of all values that are relevant for rectifying misalignments. A measurement without selecting a particular mode will provide the required individual values. Further options of the Microline 1800. The models of the entry range. Microline 1800/2 with 2 sensor heads for measuring the overall toe and camber of cars and trucks. Microline 1800/3 with 2 sensor heads and 2 LED transmitters for measuring the entire wheel alignment. The mid-range model. Microline 1800/6 with 4 sensor heads and 6 CCD cameras for measuring the complete wheel alignment. The top product of the high range. Microline 1800/8 with 4 sensor heads and 8 CCD cameras for measuring the complete wheel alignment. All models are also available as radio transmission option.